Warm greetings, everyone. Welcome back to Physics Clinic at the Red Rose Academy. So we'll see today the interesting topic that is complex numbers and quadratic equations. Actually, you know about the number system. What are real numbers, okay? Suppose if I give you an equation x square plus 1 is equal to 0, then how can you solve? Students, how can you solve? What is the value of x? Can you tell me now? What is the value of x? If you do x square equal to -1, right? Then x is equal to root of -1. Is it possible for negative roots? Okay, it is not possible, right? So it has no real roots. Okay, so what we can say, the x has no real roots, and the value of the x will be some imaginary. Okay, so in we can say back in the 16th century, 16th century itself, okay, it was believed that all mathematicians hit a brick wall trying to solve cubic equations. They kept running into square roots of negatives and thought this equation has no answer. But one brilliant Italian mathematician named Raphael Bombelli said, what if we just pretend it has an answer? So he invented a symbol for the square root of -1. That is, it is equal to I square. Okay, this I is I square, so root of I square will be I. Okay, so this is I square is taken as -1 in the square root. Okay, this I is an iota. Okay, so think of this I as a secret agent. It lives in a parallel dimension. Whenever you see a negative sign trapped inside a square root, you can pull it out as an I. Okay, say for example, if it is x square plus 9 equal to 0, if it is x square minus 9, you can easily find the answer. If it is plus 9, then it is equal to -3 or 3 square, right? So root of x is equal to, you can write I square into 3 square. Then x is equal to 3i. Like that you can write. Clear? So this is how, what is meant by I. This I is known as iota or imaginary. Okay, this I. Okay, so this is what we are going to study about. You know about how to solve these numbers and everything. So hereafter you must understand, for all root numbers has the real roots, right? Real numbers, you can solve it. For negative number, inside the root also has the solution. So that we saw I square, that is iota or imaginary number. Okay, then we'll know what are rational numbers, right? So natural numbers, it is rational, total rational numbers. It consists of integers, whole numbers, I mean natural numbers and everything. Irrational numbers also, okay, under the real numbers. So in addition to this, there is an imaginary number. That's what we saw, I square, right? So both combine. What is a complex number? Let me introduce about the complex number. Both combine. That is the real number and the imaginary number. So what is the imaginary number? We know that is all about I, right? If it is -9, it is 3i. If it is -4, -4, it is 2i, like that. Okay, so you can introduce the real number. Okay, complex number. I will introduce that complex number to you. Before that, you must understand all these things. Okay. Say for example, let you, I will teach you about the complex number. Okay, what is the complex number? It is the combination of both real number as well as the imaginary number. We can designate it with the help of a letter Z. Here itself you can write from, okay, real numbers, you know about all the number system. So if A is the real number, real part of the complex number, and B is the imaginary part of the complex number. Okay, this is imaginary part, this is real part. Okay, is it clear for you? It's very important thing. So it is also the capital Z. You can represent integers as small z and capital Z for the complex number. Clear? Then there are power cycles of I. You have to understand. So I will teach you this. What is the cycle? Okay. Now, what are the powers of iota? We can say power cycle of I or powers of iota. Okay, so I'll teach you this. Suppose if you take I is root of minus 1. We know. What is I square? You have to multiply minus 1 into 2. That is I square. So negative 1, root of negative 1 times root of negative 1. So what is root? What is root means? It is the power of 1 by 2. If there are two numbers inside, you can take one number out. So that is the power of 1 by 2. Because 2 square, we can write 1 by 2 means this. So if it is root of minus 1 times root of minus 1, it is minus 1. So inside it is root of minus 1 into root of minus 1. So it has its own algebra. So minus 1 the whole square. So minus 1 the whole square, the whole power 1 by 2. This is the meaning. So 2 and 2 gets cancelled. So minus 1 is the answer. Okay. What is an I cube? I cube is I square times I. Right? Can we write like this? Okay. Then what is I? I is negative 1. Root of negative 1. I square is minus 1. Okay. So we cannot take this one. We can take I square times I. What is I square times I? I square is minus 1 and minus 1 into I will be minus 1. Similarly, what is I power 4? I square times I square. So minus 1 times minus 1. This is plus 1, right? So if you repeat this power to 5, the same you will be getting I. Then power 6 means I square, power 7 means I cube, power 8 means I power 4, all repeated to root of minus 1. Sorry. And this is minus 1. Then this is minus I and 1, right? So this all about this cycle repeats every time, all the pass, right? So we can conclude that I power 4n is equal to 1. Okay, so where m is an integer. Can you able to understand this? Okay, where n is an integer. So fourth, I power 4 is 1. Got it? Okay, you can take it, no problem. What is I power 4? I power 4 is taken as 1. How much? So then, okay, so what is I power 18? We can write this I power 18 as I power 4 times 4. That is 16 plus 2. You can split into a multiple of 4 and then the remainder also taken like this. Since the power should be added, you can split it like I power. So what is 4 times 4? You know, right? So if you divide by 4, then 4 times 4, 16 into I power 2. Okay, so this is all about plus 1. I power 2 is minus 1. So you know that, right? What is I? I is root of minus 1. I square is minus 1. Okay, so what is this? I cube is minus I power 4 is plus 1. Like this, it will be repeating again and again. Okay, you can find plus I. Okay, this is equal to plus I. Plus I, minus 1, plus 1. Like that, alternatively it comes. Okay, then if you are given I power 2019, you have to divide this by 4 and write the remainder here. Okay, and then you know I power 4 and is equal to 1. Okay, 4 times 4 multiples you have to split out. Keep this in your mind and take this as 1 and then it will be I cube. So I cube can be written again I square into I. So that is equal to minus I. Minus 1 times I is equal to minus I. Suppose if you are given 2025 I power, then you have to divide this by 4. So I power 2024 is divided by 4. It's a multiple of 4, right? And then I power 1. So I power 2024 will be 1 times I. So that is equal to I. Can you able to understand? All these comes under this kind of thing. So this is the power. You must understand. I power 4 is equal to 1. And after it repeats, every group of 4 powers reset back to the beginning. Okay. Uh, so this is what it is. You have to understand. Okay. Now, what about the value of I power 20? If you are given a problem like this, I power 21, I power 22, I power 23, I power 24, all in addition. So how can you know? I power 21 means I power 4 times 5, that into I. So that is equal to simple. You have to find the multiple of 4. And the remainder, you can separate it into a power of I. Okay, you know, you can split like that. Okay, so the power of 4 plus remaining. Okay, so you know how to do. And then if you add all these things, it will be 0. 1 is plus 1, minus I, plus 1, like that. So this 2 gets cancelled. So you must understand sum of 4 consecutive powers of iota will be always 0. Iota means imaginary number. So this is very important point to take a note of this, students. This is very important point. Then we'll do this. Suppose if you are having I power minus 1258, okay, that will be inverse of I. So that you have to write as 1 by I power 1258, okay? And then again after that you can do with a multiple of 4, and then remainder should be written like this. Then I power 4 times 3, 14 plus 2 it will be. So I square, so minus 1, 1 into minus 1 is minus 1 here. So this minus 1 you have to place it in the denominator. Okay, so 1 by minus 1 will be minus 1 again. Okay. And then this is a challenge. This is very important problem. When you look at the problem, suppose if you are given the problem, you have to find out some small trick, and then you have to use your creativity to solve this. Okay. Say for example, in the numerator, you can find out 340, 342, 344, 348. In the denominator, you can have 339. So one subtracted from 340. So 339 into I power 1. Like that you can split. Similarly, here also plus I power 341 times I. Like that you can split 342 as. Then 344 as I power 343 into I. Then I power 348 as 347 into I. So you know all these are found in denominator. So that take I as common. If you take I as common, the terms which are inside the same term in the denominator also. So you can divide. Okay. So you can cut the terms. Here also the same terms, right? Plus I power 341 plus I power 343 plus I power 347. So same terms. You can cut. The answer is I. So instead of finding all these individual, you can also find that. So you can find all the individual based on the iota formalities. You can iota power, you can do with that. But even then it is very simple. So you have to find out the trick. So this is a small trick for you. And this is the grand finale. What is a complex number? So this is a complex number. So a real number is added up with a imaginary number. So this is a complex number. Okay. So whenever you see I square, replace it instantly with minus 1. Okay. So this is the golden rule. I told you, no, it is a real part. This one is B is an imaginary part. All about. So we can write the numbers as, complex number as Z is equal to A plus IB. And this A is purely, this A is real number, this B is imaginary number. Purely, this is A number, A is the real number, purely it is imaginary number. The Z may be, I mean, purely real number also. The complex number might be. The complex number might be purely imaginary number also. Like this. If Z is equal to 2, it can be a complex number. So 2 plus 0i we can write. Z is equal to minus 5i means it can be written as 0 minus 5. That means it doesn't have any real number. It is purely having imaginary number. So Z might be, the complex number might be the combination of both, or purely real, purely imaginary. Okay, so we can do all these things. Then this is how you will be asked question: which of the following is not a complex number? So 2 plus 3, it is a complex number. 4 is a complex. 5 is a complex number. Then none of these, it is the answer. Then we'll see. Yeah, it is very important. If you are given root of AB, then what is that? Root A times root B. It is the meaning. Since, for example, if A is greater than 0, B is greater than 0, that means positive numbers. Then you can write like this: root 6 equal to root 2 into root 3. If A is less than 0, B is greater than 0, that is minus 2. A is less than 0 and B is greater than 0. Minus 2 times 3 will be minus 2, and minus 2 can be written as root of 2i. Okay, and then root 3. So root 2i times 3 will be root 6i. Root 6 times I. It can be written like this. Then suppose if A is greater than 0, B is less than 0, that can also be done like this. Suppose if both are less than 0, if you take minus 2 times minus 3, and you can write root of 2i times root of 3i, it will be root 6i square. So instead of I square, can we write minus 1? So this is actually wrong. What is the meaning? Root 6 is not equal to negative root 6. This is very important point you must learn. Okay, root 6 is not equal to minus negative root 6. Okay, this is important thing you have to understand. Okay, then that means do not separate the two negative numbers, okay, in the square root while they are in multiplication. So this particular point you must keep in your mind. And for real numbers, if you write the function as ax plus 3y and another function as 2x plus by, if you equate these two functions, then you can write the value of a and b from this equation itself. But for complex number, it is also having its own algebra. We'll see that, okay? So z is equal to a1 plus ib1 and z2 is equal to a2 plus ib2. If it is z1 is equal to z2, if you equate that, then you have to equate like this. That means you have to equate only the real part to the real part, and then imaginary part to the imaginary part. Like that only you have to equate. Okay, so two complex numbers are equal when their corresponding real and imaginary parts are equal. So that is the real meaning. Okay, so one second. Suppose if you are given, calculate x and y in this equation, where x and y are real numbers, then how can you equate this? How can you calculate all these things? Suppose if you are having this and this is what it shows, it is the equivalent. In this, real part is 3x minus y. Okay, imaginary part is x. So here, real part is 3 and imaginary part is minus negative 6. So you have to equate real part to real part and imaginary part to imaginary part. Okay. So x is equal to minus 6. You can substitute x is equal to minus 6 here. Then negative 18 minus y is equal to 3 plus 18. So that is equal to 21. So negative y equal to negative 21. So this is the answer. Can you able to understand this? It's very easy and simple for you. So you keep in your mind, equate real numbers to real numbers, imaginary numbers to imaginary numbers. That's it. Okay. Then calculate here also the same x and y. So out of this is real part, this is imaginary part. You can equate and find out. This is very easy, no? Then this all about you can have a just take a note of all these things, okay? So there are algebra of learn complex numbers. You must understand what are all the algebra of complex numbers. We can add and subtract the complex number, and multiply and divide the complex number. Okay, we saw the equality, and then there is conjugate and modulus of a complex number. There are a lot more. So we'll see some quick practice. All these things. Okay, identities of complex number. Okay. So if there are two numbers given, Z1 and Z2, okay, then how can you add real part? Okay, real part added with real part, subtracted with real part. Okay, like that only we had to do. See, 2 plus 3i and 5 plus 2i means how can you add? Add the real part. Okay, first, and then add the imaginary part. And write like this. So subtraction also real part to real part, imaginary part to imaginary part, like that. And then remaining and all are in remaining and all you'll get. Okay. So reminding all these things, so how to do, how to use the symbols. Okay. Then we'll learn about properties of complex number, addition of complex number. All the properties, that is closure property, okay, and then associative property, okay, commutative property, everything. And I mean, there any existence of identity, or is there any existence of additive inverse, everything, additive identity, additive inverse. These are all the properties of a group. If you consider complex number is as a group, so you have defined in a set language, right? Natural number is a group. Okay, you can group a numbers into a set of natural numbers. You can group a numbers into a set of rational numbers. You can group a numbers into a set of integers. Like that you have studied, right? The same like here also you can write a set of numbers into a complex numbers, group of complex numbers. In order to prove whether it is a group or not, it should satisfy all these properties. One is actually a closure property, commutative property, associative property. Then you have to check whether identity is there, additive identity is there, additive inverse is there, everything. Okay. So this is a must for the number system. Okay. So here also it is justified in complex number also, so that it is agreed that this number, complex number also are in a number system. So first one, closure property. Closure property means if you add any to under addition. So this closure property is under addition, you can say. Okay, so what is addition? Okay, how to add the complex number also. Okay, so the complex number can be added real number to real number plus imaginary number to imaginary number, like that you have to add. And then the addition is, as like the simple, you have to use normal additive identity to add. So plus and minus, everything, right? So complex numbers, the sign also must be very important. And the complex number, if you are given any two complex number, the addition product, I mean the addition result will be the another complex number. That complex number, if you take, okay, it should be definitely a complex number. If you add Z1 and Z2, where Z1 is the complex number, Z2 is the complex number, the resultant also should be the complex number. That is the closure property. Okay. See, 2 plus 3i minus 1 plus 5i means if you add these two, real numbers should be added and the imaginary numbers should be added. So 3 plus 5, 8i. So it is also a complex number. That's what the thing is. So that is the closure property. Commutative, if you add Z1 plus Z2, the same result should be coming from Z2 plus Zi. Okay. And then properties of associative means you need three numbers. So take three numbers, Z1, Z2, and Z3. First add Z1 and Z2. With the result, you can add Z3. And so the other one, first add Z2 plus Z3, and with the result, you can add Z1. If both are same, we can say this group is justifying. This is a addition, this complex number has the property of associative under addition. Then, so existence of additive identity. What is an additive identity? Zero, right? So that means what is an identity? If you add the number, okay, with that number, with the identity, then the same number will be the result. So definitely it will be the zero number. Zero is added to the number so that it produces the same number. So if Z is the complex number, if zero is added, then zero is the additive identity. This And what is the existence of additive inverse? If you add the number and its inverse, it leads to additive identity. That is the inverse. Okay. So Z is the number, means its inverse will be negative Z. So that is the additive inverse. Then only that produce the additive identity. So what is the negative Z? If Z is minus negative 2 plus 7i, what is negative Z? Additive inverse of Z will be negative, will be positive, positive will be negative. That's it. Okay. Then multiplication. So in this, you have to do all the four products like this you'll be getting. So in between, you'll be having IB1 into IB2. That will become, okay, real part, real number. So negative B1 and B2. So this one. Okay, these two are i's. So you have to separate the real part and the imaginary part. So normal addition only, you know that, right? Okay. So real part and separate the real part and the imaginary part. It is the multiplication, right? So this is the way you have to multiply. Negative 4, okay, negative I and 12i plus 3i square. So I square means it will become negative 3. I square is minus 1. So minus 1 into 3 will be negative 3. So negative 7 plus 11i. Okay, so it is the resultant. You must write as a real part as well as an imaginary part. Then, okay, so properties of multiplication also it is discussed here. You can check with that. Right, under multiplication. So it is having a closure property. Okay, under multiplication, it is having the commutative property. Okay, then order doesn't affect, that's it. And associative property also satisfied under multiplication. Then what is the existence of multiplicative identity? It is 1, right? If a number multiplied by 1 will give the same number, that is the identity. So 1 is the multiplicative identity. What is a multiplicative inverse? If a number multiplied with its inverse should give 1. Multiplicative infinity. So what is the multiplicative infinity? Z into 1 by Z. So 1 by Z is the multiplicative inverse. What is the additive inverse? Negative Z. Students may confuse with these two things. Okay, multiplicative inverse is 1 by Z. So don't simply take inverse as minus Z. So if it is multiplicative inverse, it is 1 by Z. If it is additive inverse, it is minus Z. Then division. So division, how the division is possible? You can rationalize with the denominator. Rationalize the denominator with the conjugate. So Z1, Z2, if you want to divide, definitely you need to rationalize and separate the real and imaginary part. How can we rationalize? We have to see the denominator's conjugate. If it is 1 plus I, the conjugate will be 1 minus I. So multiply and divide. So that is the rationalization you have done in search multiplication and division, right? So the same we have to do here. And multiply these two and these two. This will be a plus b times a minus b. Since it's conjugate, so a square minus b square. So it will be 1 and 1 minus 1. So minus of minus 1 will be 1. So 1 plus 1 is 2. So remaining you can multiply normally and you'll be getting the two numbers, I mean the real part of the complex number and the imaginary part of the complex number, and divided by 2. So you can write after that 5 by 2 as the pure real part and I times 1 by 2 is the pure imaginary part. Okay.